Here goes another video on more practice with simplifying radicals. Now, of course, you know I'm about to tell you to just pause the video and try this row to see if you can handle these on your own. So, do it. Pause the video, see if you can handle them on your own. Cube root of 27, you should have just known right off the top of your head is 3, because 3 times 3 times 3 is 27. The cube root of 16, you would need to break it down using the factor tree. So you have 2 and 8, 2 and 4, 2 and 2. Circle a group of 3, box your leftovers. So the cube root of 16 is 2 cube roots of 2. The same thing's going to need to be done with the 48. So you're going to start by making this 2 and 24, 2 and 12, 2 and 6, 2 and 3. Circle 4 at a time, box your leftover, and you end up with 2 fourth roots of 3. And you're good to go. Remember, if there's nothing inside here, that's a square root. So how many times does 2 go into 4? Twice, so that's just x squared. How many times does 3 go into 3? Once, so that's just x. And again, if you think about it factor tree style, if you were to break this down, that would be 4 x's. You'd circle a pair of 2's, you'd circle a pair of 2's, and it would just come out as x times x, which is x squared. So that's it. Next row. They get a little bit trickier. So again, pause the video and try these guys on your own as well. So here we go. How many times does 3 go into 4? Once. But how many do you have left? 1. So that's 3. Or x cube root of x. Now, if you thought about it factor tree style, you would break down the x to the 4th till you got 4 x's. You'd have to circle 3, box the leftover, and you'd get the same answer. The way I say, how many times does this number go into that number? Once, you pull out 1. How many are remaining? 1 inside. Either way you want to do it is fine with me. If you want to draw 10 x's for this one and circle in groups of 4, that's fine. Otherwise, you just ask yourself, how many times does 4 go into 10? And it goes in twice, because 2 times 4 is 8, so you can pull out 2 x's. But 10 minus 8 is 2, meaning you have 2 left inside. And of course, that's the 4th root. Now, you're actually not simplified all the way, because this and this can actually be reduced. This becomes x squared and the square root of x to the 1st power. Now, how did that happen? Well, let's think about the 4th root of x squared as a fraction exponent. That would be x to the 2/4. And we know 2/4 can simplify to x to the 1/2. So that's how you get this answer. Number 3 in this row. The cube root of 8 we know is 2. The cube root of x cubed is x. The cube root of y to the 6th is y squared, because again, 3 goes into 3 once and 3 goes into 6 twice. Neither of them have a remainder. Do not ask yourself how many times 3 goes into 8, because, well, 8's not an exponent, it's an actual number. So the next example, very similar, except for the 24. You're going to have to break it down. You're going to actually break it down till you get a 2, a 2, a 2, and a 3. So you're going to circle your 3 2's, box your leftover. So you're going to have a 2 on the outside, and you're going to have a cube root of 3 on the inside, but leave a little bit of room. And now ask, how many times does 3 go into 3? Once with no remainder, so you get to pull out 1x. How many times does 3 go into 5? It goes in there once, but you have 2 remaining inside. Done. So that row was just a slight step up from the previous one. This next row is going to get a little chaotic. So, pause the video and try this row very carefully. This is where they get a little bit tricky. So remember, when you're multiplying, if the index is the same, you can multiply insides and outsides. So this becomes the cubed root of 2 times 4 is 8. X squared times x to the 7th is x to the 9th, because you add your exponents. The cube root of 8 is 2. The cube root of x to the 9th is x cubed, because 3 goes into 9 3 times. Now, when you have a radical in the denominator, you need to ask yourself how many x's you have, how many you need. So you have 1, you need a total of 3, so that means you need 2 more. So you need to multiply the top and bottom by the cube root of x squared. And now you can multiply across the top. That'll give you 5 cube roots of x squared over, and that's just going to turn into x. So now your radical's gone and you have nothing to worry about. Whenever you have a big radical with a fraction inside, you can always rewrite it as the cube root of x to the 6th over the cube root of y squared. So that's going to simplify because the cube, or 3 goes into 6 2 times, so that becomes x squared over the cube root of y squared. You have 2, you need 3, so you need 1 more on the top and bottom. So that's just going to become into x squared cube root of y over just y. So this is your final answer right here. And the last one is, well, it's fun. You've got a lot to do with that one. So what you would do again is split it for the top and bottom. So you have the square root of x to the 6th, y to the 9th, z to the 4th, over the square root of a cubed, b to the 4th. The top can simplify to x cubed, y to the 4th, z squared, and then of course the square root of y for your leftover y, because 2 goes into 9 4 times with a remainder of 1. Now that's all over. 2 goes into 3 once, so you can pull out an a, but you have 1 left inside. And 2 goes into 4 twice, so you have b squared. So really the only thing you have left to do is get rid of just the a that's in the denominator, or the radical a that's in the denominator. So this is a 2, this is 1. You only need 1 more. So your final answer is x cubed, y squared, z squared, root ya, all over, here's the tricky part, a squared b squared. Now you have to remember, when you rationalize the denominator, the square root of a times the square root of a gave you another a, but you've already got an a outside anyway, so that a times a became a squared. Okay? That one was pretty challenging with regards to rationalizing the denominator. So, here we go. Here's a little variety for you. You have 8 questions. See if you can handle these all on your own, and we'll check back in a minute. So, that's the square root over a square root. So, the top, the square root of 9, is 3. The square root of x squared is x. And the square root of y stays as the square root of y. Now, this is over the square root of 32. You would break it down using the factor tree, and you would be left with 4 root 2. And then 2 goes into 3 1 time, leaving you with 1 inside. So now you just have to fix the radical 2z in the denominator. So you need to multiply the top and bottom by the square root of 2z. And that will give you 3x root 2yz all over, careful, this is going to leave another 2 and a z, so 8z squared. That one's a little bit trickier. This one goes back to just adding your exponents. So you need to have a common denominator here. So your common denominator is going to be 12. So this is 3/12, and this is 20/12. So that's going to give you x to the 23/12. So you rewrite it as the 12th root of x to the 23. 12 goes into 23 1 time with a remainder of 11. So that's the 12th root of x to the 11th stays inside. Remember, when you are dividing, you are subtracting the exponents. So that's a 1 and that's a 1. So 5/3 minus 1 is going to give you 2/3. So that's x to the 2/3. And now you have 1 minus a negative 1/2. So that is y to the 3/2. So you need to write this as a radical. Since they have different denominators, you need to rewrite them so they have the same denominator. So this is x to the, you're going to make this 4/6, and you're going to make this 9/6. So you end up with the 6th root of x to the 4th, y to the 9th, but 6 goes into 9 one time. So you have to pull out a y, and that's going to leave you with the 6th root of x to the 4th and y cubed. That's it for this row. They are a little tricky. Adding and subtracting. Remember, you can add and subtract if the entire radical is the exact same. In this case, they are. So 2 plus 7 is 9. 5th roots of y. Done. This one, they're not the same. However, this is a square root. So the square root of 4 is 2. 2 goes into 5 twice with a remainder of 1 on the inside. Minus, this is a square root. 2 goes into 3 once. There's already 1 outside, so that becomes x squared. And then you're left with 1 inside. Now, these are actually the same. So we have 2x squared minus 1x squared, which is x squared. And then, of course, your root x. So that's adding and subtracting. This last row is just to challenge your mind a little bit. Remember, that's just adding. So this is x to the 2 plus the square root of 3. That's it. You're done. There's nothing else you can do about it. I mean, what else would you try to do? No one ever said you can't have a radical as an exponent. Just no fractions and no negatives. This, you're just raising a 1 and a 1 to the power of pi. So that's x pi, y pi. Done. That's it. And when you divide, you subtract. So 4 root 2 minus 1 root 2 is just going to end up giving you x to the 3 root 2. So this last row is actually the easiest row. It's just that the answers look a little funnier than they have. That's it. That's more practicing with this simplifying stuff. The more you practice this, the better you'll get. This is Longo, and I'm out. See you, bye.